we are going to start that part. D plus 4, 6 plus 4, 6 plus 4. So what is the voltage here? 10. 10. So what is the current is going to flow? 10 divided by 2, 5 ampere. Simple. Understood. Similarly, if I'm doing that for this part, which one? B to A, A to F, F to B. Just like you see, B to A, A to F, 5. Why? From the negative to positive, plus 6. From negative to positive, plus 5. Isn't it? Then what is the voltage here? This is 5. 11. So what is this point is 11. So what is the current is going to flow? This direction? 11 by 1, 11 ampere. Simple. In this direction, 11 ampere is flowing. In this direction, 5 ampere is flowing. In this way, just we can branch current we can solve in of the combination of cells I'm just going to connect. If the n number of cells is going to exist and each and every cell is having EMF E and resistance R. In this way, n number of cells is existing, and if externally it is connected with the resistance R like this. So what is the net current in this condition? This is going to flow. The net current will flow. So now what thing is going to happen is E. In this way, each and every EMF, we can see that each and every EMF having a tendency to flow the current in this direction. So the total EMF, if the n number of EMF is there, I can have a total EMF NE. Total EMF NE. And the total resistance, you can see each and every resistance is existing in the series. The total resistance for the internal resistance is to N into R. Therefore, this total internal resistance as well as this external resistance is existing in the series connection. Therefore, the total resistance is equal to R plus NR, like this. R plus NR. So that's why just we can see that total current which is going to flow, the I is equal to NE divided by R plus 1. We can have the current in this. Now you can see, just I'm going to just connect one of the cell in the reverse direction. What the thing is happening? You can see I'm going to connect one cell first. Reversely connected. So what's the thing? So total number in cell number, total number in. So n minus 1 number of cell trying to flow the current in one direction, and one cell trying to flow the in opposite direction. Okay. So what the thing happen here? You can see that simultaneously, if I'm going to draw two side by side cell, this cell and this cell will cancel each other. Just they're going to cancel it. But effect of the cells is going to get cancelled. So now, what is the effective cells are going to exist? If I'm just going to inversely connect one cell, that cell is going to cancel another cell. So total number of cells is existing. How many cells? N minus 2. So total EMF is N minus 2 into E divided by R plus M. Let's take one example like this kind of thing. I'm going to have 10 EMF. 1, 2, 5, dot, 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 10. Nodes. Each and every one is having R, R, R. Now, what I've done? Just I've connected the external resistance. Now, inversely, I have connected. I've just inverted. I've just reversed that connection. I've just connected. How? 1, 2, like this. So ultimately, we can observe from here that this 2 will cancel another 2. 2 will cancel another 2. Simple. So what is the remaining? So this 2 cancelling 2. So total 4. Then 10 minus 4 money effect of the 6 battery, 6 cells is going to spin. Each and every cell, just I'm going to think that 2-volt cell. 2. Each and every internal resistance is 1, 1, 1. The total current, whenever it is connected, this like in a reverse manner, the total current what? The 6 cells are effective. So 6 to 2, 12 volt I'm going to have. 12 volt. And what is the total resistance? You know, this 10 EMF, 10 internal resistance is there. So 10 into 1 is equal to 10 ohm. And if the external resistance, I'm going to think that just like 5 ohm. The total resistance 10 plus 5 is equal to 15 ohm. So in this situation, whenever I was connected like this way, two EMF sources are oppositely connected, the total current I can have like this way. I is equal to 12 volt by 15 ohm. তার মানে 3 দিয়ে কাটলে 4 by 5. I think someplace here. Just whenever one single one is going to get inverted, just connected reversely, it is going to cancel another. If second one is cancelling another. So simply, just if I think n number of total cell is there, n number of, and small n number is connected in a reverse manner, then 2n will be cancelled. 2n will be cancelled. Double of that inverted. So what is the remaining part? N minus 2n into E divided by n into R plus R. That should be the total current expression. I think it is clear, children. Okay, fine, very good. So this is the thing you can observe from here. Now, see, if cells, symmetrical cells, not like previous one, I'm going to connect it parallelly. Parallelly, and just external resistance I'm going to connect R. Each and every like this. And multiple EMF is there. Dot 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 dot, dot like this. N EMF. So now you can observe from that if this two terminal I'm going to see two terminal. What's the total EMF? E. because you can see symmetrical cells. So in these two terminal, EMF E is going to exist, isn't it? So therefore now see, you can see what is the equivalent resistance is going to exist for this part. For this part, 1 by R plus 1 by R plus 1 by R plus dot 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 N by R. R equivalent, sorry, 1 by R equivalent. Okay? R equivalent. So R equivalent is going to become R divided by N, like this one. So this part is going to become in series with this one. So total resistance R plus R by N, one R NR plus R by N. So now the net current which is going to flow through this one is equal to EMF E divided by NR plus R divided by N. So NE divided by NR expression. Net current which is going to flow through this through just like this way. The current through the external. Okay, fine. Now see what the thing. This part is clear too. So now, like we can have a separate thing. Dot 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 in the again like dot dot in cell again another. In this way, I can have M row, and with it, an external resistor is going to get connected. R. So we have to find the current. Have to find the current. So now see, what is the total EMF across this one? Huh? N into E total EMF. What is the total resistance across in one of the row? N in R. Naturally, you can see there is a M row is there. No? M row. So this every row is parallel with each other. So the equivalent for this part, 1 by NR plus 1 by NR plus 1 by NR dot 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 M times. So we can write M divided by NR is equal to 1 by R equivalent. So we can write like this way, R equivalent is equal to NR by M, isn't it? R equivalent is equal to NR by M, isn't it? So therefore, the total equivalent of this part is going to become in series with the external resistance. So we can have R plus NR by M is the net resistance is here. So finally, what the current I am going to have, that current expressions I equal to going to become NE divided by R plus NR by M. So MNE by MR plus. So the expression of the current I can have. Okay. Fine. Now see, what should be the condition that the current will vary? I'm going to, okay, like if I'm going to say that here, just think, suppose a plus, can't I write root a whole square root b minus ab plus 2ab? Can't I write? Definitely I can write. So therefore root a minus b whole square plus expression of the a plus b. Okay. So actually expression of the a plus b is a square of something plus something. So when the a plus b is going to become least value, it is going to have the least value when the square is going to become 0, isn't it? So the least value of a plus b is going to exist when this part is going to become 0. Then root a minus root b is equal to 0. I can write a is equal to b. A plus b, any two variables a plus b, having this addition is going to become minimum when a and b are equal. Therefore I can write like this way, for the maximum current I max, I can write that m into n into e divided by mr plus nr, when current maximum, when it is going to happen, when this and these two are equal. So when condition is that mr is equal to m. When the condition, just like a and b are equal, then this one is going to become minimum. When this is the denominator is going to become minimum for this condition, then the current is going to become. So the condition for the maximum current is going to flow through this matrix system. The condition is this: mr is equal to n. I think it's body. Okay, fine, very good. So now we're going to apply just whatever we have. I think the children, it is clear to you. Body. We are going to apply the Kirchhoff's law to calculate the condition of Wheatstone bridge. Balanced balanced, like see what is the shape of the Wheatstone bridge? Like this: first, second, third, fourth, and another resistance. This have connected a cell. Okay, if this resistance, I'm going to think that it's a P resistance Q. This is R S, called Wheatstone bridge. If it is balanced or not, how to check? We have to see that through this middle resistance. Suppose it is a galvanometer. Let us say galvanometer. Galvanometer is a special device through which, if the current is going to flow, there is a pointer existing, it will deflect. Then we can understand that some current is going to flow. So the balance condition of the Wheatstone bridge is that when there is no current is going to flow, no current, then I can tell this bridge is balanced. Okay, so we are going to use Kirchhoff's law to find the condition. Kirchhoff's loop law, Kirchhoff's second law, we are going to find the condition. So let us think the loop for A, B, D, A. One, So if you think there's a current is coming I, there's a two branching of the current. This is I1 and this direction I2. I1 is going to come here, and if there is no current is going to flow through this branch BD, there is no deflection existing in the galvanometer. So we can understand that the I1 is going to flow this one, full I1 is going to flow through this resistance. Similarly, the I2 is going to come here. I2 will flow through this one, I2. This I1 and I2 is going to meet it here, and that combination of the I1 plus I2, I is equal to I1 plus I2 is going to return back to this one. Okay. So now if I take the loop A, B, D, A, what I can write from here, you can see from A to B, what is the thing? Minus I1 into P, because we have moved in the direction of the current, therefore the voltage drop negative. Then B to D, there is no current. Just assume there is no current, so there will be voltage drop 0. Then from D to A, because we have we moved in the opposite direction of the current. So if I'm just going to move in the opposite direction of the current, so if I move in the direction of the current, that voltage is negative, but in the opposite direction of the current positive. So plus I2 into Q. So just again from D to A, total closed path is completed. Therefore, summation of the all voltage drop is equal to 0. So we can write like this way: I2Q is equal to I1P. 1. I2Q is equal to I1P. Now, for the second loop, for the loop BCDB, for the loop BCDB, I'm going to move from B to C. B to C minus I1 into R. C to D, just in the opposite direction of the current, plus I2 into I2 into S. And again D, there is no current, therefore it is equal to 0. I2 into S is I1 into R. Okay. So now first equation number 1 divided by equation number 2, what the result is going to come? I2Q divided by IS, I1P divided by I1R. So we can write I2 cancelling, I1 cancelling, Q by S is equal to P by R. Therefore, finally, we can write R by S is 2P by Q. This is the condition for the balanced physics. The balanced physics bridge, if this any kind of bridge is going to exist, then the ratio of this by this by this is equal to this by this. If this is happening, then I can tell the through this middle branch there is no current is going to. Simple. Do some applications bridge like this. If I'm just going to think about more I'm just buying it. What is the current? Now see, you can see this one and this one, 2 by 4 equal to 6 by 12 equal to half. Both is same. Naturally, there will be no current is going to flow. No current. Naturally, current is going to by D it is here it is current is here. So simply we can omit this part because we just can eliminate. So how this thing is going to happen? Because the same current is going to flow through these 2 and 6. These 2 and 6 are going to become in series, and 4 and 12 is going to become in series. Okay. So we can redraw the circuit like this way. 2, 6 and 4 like this. Okay. That's then 2 and 6 in series, 8, 4 and 12 minus 16, and ultimately we can draw 8 and battery going to have 10 volts. So this 8 and 16 are in parallelly connected. That therefore just we can have the equivalent resistance is equal to 18 by 8 plus 6. 8 into 16, denominator we're going to have 24. So what the result is going to come? 8 দিয়ে 24 के काट ले 3. 16 by 3. The resistance is going to come equivalent 6 by 3. Okay. So now finally we want the current here. I want the current here. So therefore the total current we can have like this way. Total voltage divided by equivalent resistance 6 by 3. So 10 into divided by 6 cut by 2, it is going to become 8 5. Math of the 15 by 8 ampere. The net current going to come out from the cell, the battery, it is by 8. Each and every side having a resistance like this. I want to find, and each and every resistance is R. R. I want to find the equivalent resistance. I want to find equivalent resistance across the diagonal. Like this to diagonal point A, B. This thing I'm just going to connect a source. Source voltage V. Now, if I'm going to think that the current is coming here, 6I. Let us think to solve this one. It is symmetrical. Each and every one is symmetrical. Though. So they're going to divide like this. In this side, 2I. In this side, 2I. In this side, 2I. Because 6I came distributed. This. This point again is going to divide equally. I. Okay. Very good. Then this 2I getting divided. I. Okay. Then this 2I getting divided. I. Okay. So now you can see this 2I divided I. This 2I divided I. This 2I divided I. Then you can see this I and this I combination, this 2I. Okay. No problem. This I, 2I. Okay. this I and this I, again this is 2I. Okay. So now if I'm just going to choose a path, suppose this is point A, point B, this point is C. I'm going to go from A, this point E, A, E, C, B, like this. I'm going to A to B. I want to find the equivalent resistance between A and B, not diagonally opposite. So I'm just moving A to E, E to C, C to B. So now what I can find from here, A to E, current is 2I, then R into 2I, voltage drop. E to C, R into I, because this is a voltage drop, plus R into 2I across CB, R. So what is the total voltage? The left 2IR, R, 5R into I, total voltage drop across A to B, total voltage. Okay. So now, if I'm going to see that, I am going to have a equivalent resistance, that is R, and the net current is I, voltage V. So we can easily write it like just like this, I R, net voltage V. So this 5RI, that is also voltage V. This is also 6RI, voltage V. So now this and this has to be equal to 6IR equal to IR. Therefore, this II getting cancelled, this R by 5. So therefore, the equivalent resistance I can write 5R by. Move, then from here to here, suppose D. And B to A plus 6, A to D plus 4, 6 plus 4, 6 plus 4. So what is the voltage here? 10. 10. So what is the current is going to flow? 10 divided by 2, 5 ampere. Simple. Understood. Similarly, if I'm doing that for this part, which one? B to A, A to F, F to B. Just like you see, B to A, A to F, 5. Why? From the negative to positive, plus 6. From negative to positive, plus 5. Isn't it? Then what is the voltage here? This is 5. 11. So what is this point is 11. So what is the current is going to flow? This direction? 11 by 1, 11 ampere. Simple. In this direction, 11 ampere is flowing. In this direction, 5 ampere is flowing. In this way, just we can branch current we can solve in this direction. There's a pointer is there. It will show deflection, so we can understand the current is flowing. So now see, if this is P R, let us think this. So what the thing happen here is like this P and the pointer of the galvanometer is connected at this point. What we can observe from here? Can you imagine this P and this part is another part of a resistance? This part is another part of the resistance, and this resistance R is existing. This is P, this is R. So we can think this part is Q and this part is S. Can't I think that? So now this galvanometer connected here, the pointer can be shifted here, here at different position. So pointer is shifted in such a way that I can get a null point. Null point means there will be no current is going to flow through the galvanometer. So when there is no current is going to flow through the galvanometer, we have to understand the condition of the Wheatstone bridge. Balance condition of the Wheatstone bridge is satisfied, isn't it? Huh? So therefore, just you can see that if this length is L, so I told that this length is 100 centimeter. This remaining part will be 100 minus L. And the resistances of this wire is directly proportional to L. Why? R is equal to rho L by A. With resistance is directly proportional to length. So therefore, when the balance condition of the Wheatstone bridge is going to get satisfied, we can write like this way: P by something constant into L, because this is a resistance. Something constant multiplied by length is a resistance. At the balance condition, I can write R by that constant 100 minus L. So this K getting cancelled out. I can write P by L is equal to R by 100 minus L. So we can write, if the P is known and R is unknown, we can write like this way: P into 100 minus L by L. This is one of the important formula used. So unknown resistance can be found by this process.